Thank you, and good afternoon, everyone. Thank you very much for the invitation, and apologies for presenting this in English. I will try to be clear, and if there's any question, please discuss with our GF representatives that are on the booth, or they will come after this presentation. If you have specific questions about what I'm going to present, then you can ask them in German. So apologies for this. Next time, I promise I will do it in German. Thank you very much. So I work at the GF Machining Solutions. I'm responsible of innovation in the side of digital transformation. So for about now 2 years, we've been setting up a team, people and experts and engineers, in order to develop specific solutions for our machines and our customers for taking them into this Industry 4.0 journey. So everyone is talking about Industry 4.0. There's a lot of noise and buzz, but I think what is difficult is to find what is exactly being done, what is implemented. And this is exactly what I would like to show, the efforts that we are doing in order to implement, to show that we are going little by little into this Industry 4.0 world. So this is the presentation, the agenda. So I will try to do a short explanation of what is GF. I present the company, GF Machining Solutions, and then going into the specific details of our Industry 4.0 solutions. So first of all, who are GF, Georg Fischer? So we are part of the big group, a Swiss group, who is based in the Schaffhausen. It's been more than 200 years that this group exists, and the first division has been working in the piping systems. It is one of the biggest divisions, and we have the second one working in automotive parts. The third one is the smallest one and is the most complex, is the GF Machining Solutions. So we have reached last year nearly 1 billion Swiss francs, a little bit less than 1 billion euros, and we have more than 3,000 employees around the world. What we do? Please take a seat, gentlemen. I'm sorry, the presentation is in English, but there will be people answering to your questions in German afterwards. So we do machines, so different types of machines. We have started in the past with the first technologies were about EDM, electric discharge machines, and little by little we grew up the portfolio of technologies by incorporating milling and very lately laser technologies from the side of texturing and additive manufacturing. And of course, we have been in the automation and tooling with our company System 3R from Sweden. We've been working in automation for more than 20 years with this group, and we have now very interesting integration solutions for our machines. It's one of the topics that I would like to address this afternoon. And of course, a big part of our activities concern the customer services. And you will see that a big part of our Industry 4.0 solutions are coming along the service division. So here we have an example of our product that you can see downstairs. If you go to the GF Machining Solutions booth, you will see different types of machines, and you will see in particular the wire EDM machine, the die sinking EDM machines, examples of our milling machines. And we don't have here, but this technology is becoming more and more popular, laser texturing and additive manufacturing. We are also providers or suppliers of tooling and automation solutions, robots, and of course, integrating our machines into the factories in order to make the whole process intelligent and automated. So we are present around the world, but our main factories are in Switzerland, and in Geneva, in Lausanne, south of Switzerland, and we have also factories in China for the local market. And we have more than 150 sales and services companies around the world. So what is our Industry 4.0 strategy? We all start with a strategy. What is our vision? And our vision is mainly to focus on providing a solution at 3 levels. We believe that the problem that addresses Industry 4.0 is basically information. What is new that you have in your pockets, and that is really, really important now, is the information. So whenever you need information about where to go, what train to take, what bus, if you need a taxi, if you need information about leisure activities, then you have everything in your pocket. And this is the real revolution. You can have intelligent information in your hands. So the real industrial revolution, Industry 4.0 in manufacturing, it's also about information. It's not really around the smartphone, it is around the machines. And what are the big issues with these machines? The big issue is that it is not as simple as a smartphone. These machines are very complicated, and you need years, and most of you have spent years learning how to deal with these machines, how to make them performant, how to make the part very precise, and how to use this in companies like Metzler for doing very high precision components. So this is very difficult, and it's becoming more and more difficult because for doing this kind of objects, you need high precision machines, but you need to combine different types of machines. You don't have only one type of machines. You have EDM, you have milling, you have laser, additive manufacturing is coming. So more and more technologies which are difficult to integrate into our knowledge. So these machines have to become as simpler as a smartphone in the future. So the first barrier that we want to break is the expertise barrier that the people, the operators, the engineers need in order to handle these so many machines. This is one first barrier. The second is, as you know, in order to do this kind of very complex objects, you need different types of technologies in machines that are in the shop floor. EDM, milling, laser, turning, grinding, and so on. So in order to make this smoother, in order to make it faster, in order to optimize the process, simpler, then you need the machines to communicate between them. So the next barrier that we want to break is the machine-to-machine communication. This is very important. And the third one is the information that comes from the factory, the shop floor, into our management systems, the factory management systems. And this is one of the very important topics that we have to address, is how to get out information, valuable information from our machines into the management, planning, ERP, MES systems of your factories. In order to have, for these systems to have, and for you to have all the required information to make a highly productive system. So this is our strategy, and what we want to do, and it is written in our strategy, I would say, book. GF Machine Solutions will be the preferred partner for the global precision machining industry during all phases of the life cycle. This is what we want to do. All phases of the life cycle, that means during training, when you learn how to use the machines, during the execution phase, how you use the machines, how you exploit in the shop floor, and then how you maintain this. This is the full life cycle view where we want to be the preferred partners of the users. So that goes into the following direction. So first, in order to do that, we have to digitalize all the information coming from machines, which is, I would say, not that difficult. These machines are fully digital. Some of them have analog components, but we can make them digital. Out of them, we have to connect our machines. We have to be able to extract and to provide you this information to different systems. And then we can implement a different kind of collaboration. Collaboration between machines, between engineers and machines, between machines and factory management systems. We have to break these borders of information. So in the end, the vision is that we have a system that is able to communicate. Machines can able to communicate between them and the operators, the engineers, management systems, in order to go towards a system which is self-optimizing, which is able to adapt itself towards what you need. That means to have a system which is not having planned interventions, maintenance, that you don't have to stop and to interrupt your production process, and you have highest quality and highest productivity. So that is easy to say. How to do it? So what we implement in this is, in order to break these barriers of information, we implement what we call the IoT stack, the Industrial Internet of Things. So this is exactly what you have in your smartphone. So in your telephone now, so the internet is going into every object that we use. And so this is exactly what we want to do. We want to put the internet, or the internet, industrial internet, secure connectivity to all our devices and components. And this to different levels. I'll tell you before that we need to break barriers between people and machines, but also machines and machines, and also machines and information system management systems. So this is exactly what this IT system, IoT stack, tries to develop. So we are translating this into our Internet of Things system for GF Machine Solutions, going from our machines, our controllers, into different layers of software where we will have applications that will help you to design, to produce a code for the machine, to advise you in order to do the best work with our machines, and then to get this information out of the system into an upper layer where you have applications that can be downloaded into mobile devices, and you can have information from your machines into your smartphone, your iPhones, or computers. Then, out of this information world, we can manage to implement little by little intelligent systems that can help you to grow this, to grow your market, your products, with the support of this information from the machines and the intelligent processing that you can develop out of this information. So I will give a more detailed example on that. So just to tell you about our roadmap and strategy. So last year, what we did first, as going along this strategy, we implemented our first connectivity solution. So the first thing to do is to digitalize. This is a thing which is done. Digitalize all the information coming from the machine. Second thing, connectivity. And this is the second wall that we're breaking now. All our machines are now able to connect, to deliver data, information through standard protocols. So, and we have our first applications, which we call the infrastructure R-Connect, which is able to deliver what we call live remote assistance, LRA, which is a system that gives you information, data from machines, from what is happening with machines. If there's a problem, if there's an issue, if there's a warning, you can have this information remotely to any device. So you have also this integrated in your smartphone. This is called the messenger application. And then the live remote assistance is the interaction between our technicians from the field and your technicians and your operators, your engineers working in the machines at the factory, in order to make this smoother, to have a faster reaction to any problem that arises at the shop floor. This is the first step, and this is a very important step, taking advantage of this connectivity between the machines and in the internet. And then we have our first, at the second level, solution, what we call process solution, that takes advantage of the facility, of the possibility of communication between machines. So it's not anymore machines with people, it's now between machines. And this is what we call, and I will show this more in detail, the true solution. That means a system that is able to produce a part which is very precise by providing information to different machines, and between them they understand where is the problem, is there a problem, is there an accuracy, and they solve it in an autonomous way. E-tracking is another intelligent system that helps you to detect any defect coming from the signals of these machines. Little by little, this solution will develop. We will have more sophisticated monitoring process in the coming years solutions. We'll start to manage big data because all these machines will deliver more and more data, and this historic data will be taken into, I would say, a server or a cloud, and from that we will start to work more intelligent applications. So this is at the level of research now, because in the next years we intend to develop this into sophisticated, I would say, solutions, what we call a digital twin, having the virtual machine model. Everything which is happening, what is happening with your machine will be able to be virtualized, and all this information can be exploited in order to produce optimization based on a dedicated software. This is what we are working on at the research level. Then, of course, predictive maintenance, the fact that in the future all this information coming from the sensors from our machines, we'll be able to deliver information for elaborating models, prediction models, that will help to tell, at this moment in time, your component, your spindle, your machine is about to fail. And then we can anticipate a service. And you don't stop the production process. This is what we call predictive maintenance. And little by little, we're implementing solutions for every component. This will be deployed in the coming years. Thanks to this e-tracking or ER-Connect connectivity framework. Thanks to the connectivity, thanks to the internet. So going more into the concrete solutions that we have, we can map the real solutions now, what we are doing in the market as an industrial process solution. So you see here a picture of what we can have ideally in a factory with all our machines. We have milling machines, you have Edm machines, you have laser machines, you have also in this world robot system, automation systems, you have CMM, measurement machines, you have information systems, ERP, SAP, and so on. Now we are able to integrate all this information thanks to our connectivity solutions. And one of the first examples that we want to show now, that we are able to show now, is the true solution. True stands for true response to customer expectations. And it is in fact a system that helps the machines to communicate between them in order to deliver the highest precision part for a multi-stage manufacturing process. That means where you need different types of machines to achieve a part. This is the case very often in mold manufacturing, where you have to use milling and EDM and sometimes laser, now more and more. And, of course, with the help of robot systems, automation systems. This is the first example, communication machine to machine. The second one is, of course, how to put this system or this concept into the execution level, the shop floor, with our workshop manager. And then we have also important intelligent solution that comes out at the machine level. That means the machines have now different sensors, and these sensors are now able to deliver information from consumables, the state of components, and this information is valuable for you You can, as you will see, for instance, have information about the status of the spools in Edm machines in order to not to interrupt, I would say, a production process during the nights or the weekend. And you can plan ahead with your stock what can be done effectively without interruption. You have these new solutions about e-tracking. I will not develop this. This is particularly important for aerospace applications, where you have to detect any particular defect arising during the manufacturing process. And then all this world is delivering information towards our R-Connect pipeline, data pipeline, where you can have all these indicators of quality, productivity, status of machines, need of maintenance in your pockets, in your smartphone or in a laptop or wherever you are. This, of course, using a secure infrastructure, cloud infrastructure. So this is little by little what we are developing. This is real. This is what we are doing, what we're putting now into your hands this year. So in more detail, going into the first one, the true solution, where I want to underline that we try to develop a system that helps the machines to communicate between each other. But what kind of data they communicate? What is important? In this case, we have a partnership with Autodesk in order to have, I would say, from the design stage, where you have a design of your part, a definition of the different technologies that you will use in order to manufacture it. For instance, if it is a mold, then you need Edm at one particular segment. You need another feature with milling. You need another feature with laser. So you have a software system with Autodesk that helps you to define what are the manufacturing steps in an easy way. And then we have the generation of codes. And the trick is here. The generation of code is not coming directly from the point where you have decided which technology you use. You do this after finishing the first stage of your process. For instance, you have in manufacturing of molds, you have to do some cavities with electric discharge machine, die sinking. Then you need some electrodes. Then for doing these electrodes, you need milling. So what we do is to define the code for milling. We machine the electrodes, and then in an automated way use a CMM machine in order to measure the accuracy of the electrode. And then before producing the code for the next stage, the die sinking machine, we integrate all these deviations into a real geometry of the electrode in order that the code that will be delivered for the machine, the die sinking machine, will correct any deviations that comes from the previous process. So it is a way of communicating small deviations from one process into another process in order to compensate and give you the highest accuracy in an automated process. So this is completely new because you don't know what is the result. You have a few micro deviations in one side, but where, you don't know. And then you measure automatically, and then you produce a new code which compensates these deviations by another machine. And this in a full automated way. This is what we understand by communicating information, valuable information from one machine to the other. And then we see here a small video. You can see how this process is really working. So you see this true solution can be, I would say, applied to a manufacturing of a connector. For doing this connector, then you need some Edm processes because you have very specific, I would say, details that you cannot do by milling. And what you do is to design the electrode for doing these Edm processes with the milling machine, but taking into account what you have as deviations from a measurement after the electrode has been machined by milling. So these deviations will give you information about how to produce the best coat, the highest accurate coat for making this Edm machine. And then this system is currently working, so you can use it. You have to use our software systems, our machine systems, and a CMM system. In this case, we use a CMM from Zeiss, but any other CMM machines can be integrated into the solution. So what is new is that we can now integrate this knowledge, because this is a new human knowledge. Normally, this is the kind of things that you engineers or your engineers do at the shop floor in a very, I would say, long way. You need a lot of expertise, you need a lot of time, you need a lot of people and resources for doing that. So we try to deliver you a solution which is automated, easy to use. So this is one very important example of how this Industry 4 is going into manufacturing with communication facilities of machines. This is currently now being tested, and we expect some results in terms of accuracy, how much we can gain into accuracy, because if you integrate these machines into a shop floor, if you don't have this system, then with some work, with a lot of work, you will have 10 micros deviations, but it's very difficult to downsize these deviations. So the goal is for us to reach much less than 10 microns. They go into read the micron level accuracy in order for you to not to do more efforts in the level of engineering or integration of the solutions for having highest accuracy in an automated cell. So this is being proved now at Formtechnik. It's a Swedish company making machine or molds and dies. We have another example that you can show, you can see downstairs. So we have this wire Edm machine. This is very well known. This high precision a technology using wires and spark discharges. So it's very unique because you can have very fine features with wires going below the 100 microns, 50 microns. And it is very useful for punching applications, more and more aerospace application. What is interesting is that now these machines are becoming more and more, I would say, sophisticated in the sense that they are now able to deliver with a particular RFID chips integrated into the spools, deliver information, exchange information with the machines, so the machines knows and puts the stamp, puts the information on the machine, on the spool automatically, in order to update how much wire is still left on the spool. So you can imagine a lot of things coming out from that. You can imagine, for instance, that you can manage your stock. You know exactly how much wire you have in every spool you have in your stock. And you can say, yes, I can choose these types of spools or these spools for my job that needs to hold during the full night or the whole weekend. I can still use this part of the spool. This is something that you don't know exactly, but thanks to this information, again, exchange, automated information exchange between spool and the machine, you are able to manage this in a more intelligent way. Same is coming up with the filters, for instance. We are now able to, with the specific algorithms, to calculate exactly how much is the lifetime left for your filters. Exactly what you have with your car when you need to refill the tank. You know more or less how much benzene is left. So exactly now what is coming up in these machines with the different types of consumables. You can see examples of these applications downstairs with this Cut P series new machines. This is another example. Huh? So the idea is to optimize wire and filter consumption, to reduce human errors and quality. This is something that can happen. And of course, you have management and traceability and some ergonomics as well. Easy to use systems. So the idea is to have something which helps you to have a process which is not interrupted. We have, of course, interfaces at the level of the machine that help you to deliver this information, and of course, some also help to cost calculations. It is also very interesting how much this process will represents in terms of costs. Is also an important information for you in order to undertake this or that job with the following spool or not. Again, it's another way of communicating with the machines. And then we go to the next level, which is the information from the shop floor to the management systems. And thanks to our R-Connect infrastructure, we're now able to connect all our machines. All our different technologies are able to provide data, different type of data and information to this R-Connect system in different standard formats. And then you can display it, all the warnings, all the messages, and you can exchange also information with our services through distance with this LRA, this Live Remote Assistance System, which is now available, and the messenger. That means all the warnings, all these important messages coming from your machines are now able, you're not able to have it on your smartphones. This is really fresh news. So we have here another way of supporting this communication with the management systems, because all this information coming from the machines, the status of the job, how much time is left, how much time this takes. So this can get to information, MES systems or ERP systems, in order to have an integrated system of intelligent management of a factory flow, production flow. This will come little by little. So we are developing standard interfaces, and then different types of MES and ERPs will be able to get this information in order to have the full picture of an intelligent factory. The factory that is working without interruptions or with minimum interruptions, which is able to replan in an autonomous way a different job with different machines. Many things that will come out with this communication, basic communication out of the machines. So we have here just another video where we see a part of these results, but also part of our vision from this R-Connect platform. So this R-Connect cockpit will help you to get this information about the different KPIs, indicators of quality, productivity of your machines. Live Remote Assistance will help you to have information exchange in real time with our technicians in order to avoid expensive, I would say, service work on site. And of course, in the future, predictive maintenance. So we have already some results which will help you to predict the lifetime of some components, in particular spindles for a milling machine. And the messenger, which is available now in your smartphones. So this is a part vision, but part real now. This is the important message that I want to deliver to you now. So again, this is the cycle of information exchange, the support that you will have with this R-Connect Live Remote Assistance system. You can have more details with our representatives downstairs, the GF Machine Solutions booth. I want to show one example, which is coming up, so you don't see it now. So what you can have with this R-Connect system is that remotely you will have information or data coming from all the components of the machine. And here we have, for instance, very interesting data of the temperature the torque, all the sensors, the accelerations, the vibrations, all the sensors that we have in the spindle. And normally they are displayed in the interface, and you can have information on what's happening, how it's going on. And with some knowledge, then you can say, oh yeah, there might be a problem with the spindle, or I should take care of the system now. So now the systems will become more and more autonomous, intelligent, but first you will have the information available in real time everywhere. So here you see an example of a display that will come up very soon of our process monitoring solution, dashboard, with display of all the parameters, temperatures, torques, vibrations in your machines. But more importantly, if there are levels which are becoming dangerous for your machine, that means that you're reaching a level where it is important to take care of the maintenance of the component. And this with a particular probability, with a particular, recommendation for service. So here, in order to show you that this is working, you can see a small video where you can choose around the world. You are connected to different factories in the world. You can choose your machine, and you can choose the sensors that you will have displayed in your machines, and you can assess the status of every component. And then with these models, you will be able to tell, yes, this machine needs a maintenance in the next few weeks. So this is working, but this will come little by little into our solutions around the R-Connect infrastructure. I think that's all. I just wanted to give you an overview of what is our vision, what is real now, what is happening, what can we offer, and we are really proud about these results, these products. And I think as a summary, we would like to say that Industry 4.0, how we deal with it, it is try to deliver valuable information to the user, to break these information barriers between you and the machines, but also between the machines and themselves. It is a kind of new informatics engineering, and this is the real revolution. And then around you can develop different types of smart applications. And our first, I would say, examples in this direction are the true solution, the smart wires, and the R-Connect infrastructure developments. So we break these barriers, these walls, in order to deliver you more precision, quality, and productivity. That is the main, I would say, idea of our concept and results in this field. Thank you. Thank you.